Good morning everyone. Myself Kausar Momin, 9th standard subject Science 1, chapter number 13 Carbon, an important element. In this chapter today we are going to discuss about hydrocarbons, carbon dioxide and methane, occurrence, properties and uses. Hydrocarbons, basic organic compound. Along with carbon, the element hydrogen is also included in most organic compounds. The compounds formed from only carbon and hydrogen are called basic organic compounds. These are also called hydrocarbons. Before this, in the previous lecture, we have seen a structure forms by carbon, which we are getting graphite, diamond. Over there is a combination of carbon itself only. Now here there will be a combination of carbon and hydrogen, and this compound which is formation of combination of carbon and hydrogen are called basic organic compounds, or we can say it as hydrocarbons, because it is a combination of carbon and hydrogen. Because of it is combination of carbon and hydrogen, that is why we can name it as hydrocarbon, or we can call it as basic organic compounds. The electronic configuration of carbon is, as we know, 2,4. If 4 electrons are added to the second orbit of carbon, its octet becomes complete and its electronic configuration becomes stable, like that of nearest inert gas neon 2,8. Therefore, the valency of carbon is 4. However, this occurs by sharing of electron rather than give and take of electrons. In other words, a carbon atom can form 4 covalent bonds with other carbon atoms or atoms of different elements. Obviously, carbon is having its valency 4. To complete its octet, carbon needs to share their electrons, or give or take electrons should be there. When carbon atoms share 1 electron each with 4 hydrogen atoms and forms for 4 CH bonds, that means CH4 molecule is formed, and CH4 molecule naming as methane. So this way carbon is formed, shares its 4 electrons with 4 hydrogen. So carbon is sharing its 1 electron with 1 hydrogen, 1 electron with 1 hydrogen, 1 electron with 1 hydrogen, 1 electron with 1 hydrogen. So this is the way this CH4 molecule form. So this is the structural formula for methane, or we can make a dot model of methane also, because of 1 electron of carbon, 1 electron of hydrogen. That's way 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 hydrogen, 1 carbon, 1 hydrogen, 1 carbon and 1 hydrogen. So hence we can make dot structure of methane also. This is the way of dot structure. So we can name the structural formula electron dot model of methane. Okay. So we are having properties of covalent compounds, and these are: covalent compound have low melting points and boiling points. Generally they are insoluble in water and soluble in organic solvents. Insoluble in water and soluble in organic solvents. They are poor conductors of heat and electricity. suppose we have seen the name which was methane, METHANE, methane. Its formula is CH4. When the number of hydrogen is going to decrease in it, suppose if it is going to become CH3, then its name is also going to change. Instead of methane, it will be methane. And if we are changing the name based on decreasing number of hydrogen, then suppose we are having C2H6 is ethane, then C2H4 is ethene, and C2H2 is ethyne. So as the number of hydrogen is decreases, then their name is also going to change, ethane to ethene, then ethyne. This is not a part of this topic, but to understand this topic we should know about this thing. Okay, if the number of hydrogen is getting decreases, then the parent name is also going to change, ethane to ethene, ethene to ethyne. Number of hydrogen is decreases. So please keep this thing in your mind. We are going to discuss about here saturated and unsaturated hydrocarbons. A carbon atom exhibits a characteristic property. It can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. The hydrocarbons having only single bond between carbon atoms are called saturated hydrocarbons. For example, ethane, that is C2H6, which is having a bond, single bond CH3. If you will count the number of carbon and hydrogen, you will get C2H6. Then propane, CH3, number of carbon 3 and number of hydrogen is 8. That means C3H8. So here you can observe single bond is there. That is why we can name it as saturated hydrocarbons. Some hydrocarbons have multiple bond between two carbon atoms. A multiple bond can be double bond or a triple bond. Hydrocarbons having at least one multiple bond are called unsaturated hydrocarbons. Suppose ethene. Ethene has a double bond. Ethyne has triple bond. So propane has here double bond. Propyne has triple bond. You can observe here, you can count as I said to you previous. Number of hydrogen is going to change, then their name is also going to change. So that is why naming is changing, and why this single bond, double bond, triple bond is forming. This study you will have in next standard. So you just have to consider about with saturated and unsaturated hydrocarbons. When we are considering a saturated hydrocarbons, over there we are getting single bond and all N is there. Ethane, propane, all N is there. So it comes with the saturated hydrocarbons. But ene and ine means ethene, propene, ethyne, propyne. With that double and triple bond is there, and those comes with unsaturated hydrocarbons. Suppose if the distinguish is there, then you can distinguish very nicely that it has a single bond or it has a double triple bond, and the name is parent name is going to change with ane and ene and ine. Okay, so this way you can differ very nicely. Next is carbon dioxide. Its molecular formula is CO2. Carbon, and how many oxides are there? 2. So that is why dioxide. Carbon dioxide. Its molecular mass is 44 and its melting point is minus 56.6 degrees Celsius. Occurrence. Carbon dioxide occurs in the air in the free state to extent of about 0.03%. Exhaled air contains about 4% of CO2, and CO2 means carbon dioxide is present as a salt in chalk and Shahabad tiles, marbles, limestone. CO2 carbon dioxide is given out in the combustion of wood and fossil fuel coal. No need to perform this, try this experiment and all. No need to do all these things we are going to perform in the laboratory. So please don't focus on this kind of experiments. Whatever I am teaching you in this video, please concentrate on that also. That only. Next is physical and chemical properties of carbon dioxide. Carbon dioxide means CO2. Please keep in your mind carbon dioxide means CO2. How you are you are keeping in your mind oxygen for O. So in that way carbon dioxide is CO2. So physical and chemical properties of carbon dioxide. So we should have to perform this experiment, but we are not performing over here. So no need to consider the color, form and all, because we don't know about, because we won't perform over here. We'll go directly with uses of carbon dioxide. Carbon dioxide is used to make ready drinks. Solid carbon dioxide is used in cold storage and also keep milk and milk products and frozen substances cool during transport. It is also used for getting special effects of mist in dramas and movies. CO2 obtained by chemical reaction or kept under pressure is used in fire extinguishers. Liquefied CO2 is used to remove caffeine from coffee. Liquid CO2 is used as solvent in modern eco-friendly dry cleaning. Plants use CO2 in air for photosynthesis. This is the common point which we know. Next topic is fire extinguisher. A fire extinguisher contains sodium bicarbonate powder. There is also dilute sulfuric acid placed in a glass capsule. The capsule breaks on pressing the knob. The sulfuric acid comes in contact with the sodium bicarbonate and the two react chemically to release carbon dioxide, which is CO2. Here you can observe this is the cylinder, and inside the cylinder, this one is the knob. Here white capsule. In that sulfuric acid is there, and when this sulfuric acid is contact with powder of sodium bicarbonate, then after chemical reaction carbon dioxide releases. So how it releases? This is the internal structure of fire extinguisher. I'll show you in the video how it works exactly. Carbon dioxide based fire extinguishers do not cause corrosion and are non-conductors of electricity. Therefore, these are used when electrical and electronic equipment catches fire. Carbon dioxide based fire extinguishers are used to extinguish small scale fire. It is beyond their capacity to extinguish a big fire. In modern fire extinguishers, liquid and solid carbon dioxide is filled under pressure. On reducing the pressure, it becomes gaseous and comes out forcefully through the horn-like pipe. Chemical reaction for this. This one is the chemical reaction. NaHCO3 means sodium bicarbonate is react with sulfuric acid. Then this solution forms. You can observe here CO2 comes out. Nowadays many types of fire extinguishers are used. See this video. You can clear with every doubt. This is the cylinder. Everything you can observe very nicely. Here's sodium bicarbonate and sulfuric acid in this white glass jar. When while using this, we have to remove this cork. As we discussed with theory, we have to press this switch. When sulfuric acid gets react with sodium bicarbonate, that time we are removing the switch. First we have to remove the switch, cork, then press. See the video carefully, you will clear how exactly carbon dioxide comes out. See, this is the process. Carbon dioxide is coming out after chemical reaction between sulfuric acid and sodium bicarbonate. So this one is the internal structure of the fire extinguisher diagram. This can come in your exam to draw a diagram for fire extinguisher. So you should know about the things which are present in it. First of all, the knob, capsule. In the capsule, sulfuric acid is there, and in the cylinder container, powder of sodium bicarbonate. And this one is the chemical reaction for the same. Next is methane. We have to see over here occurrence of methane, its molecular formula and uses, properties, all these things we have to see. See, first of all, where we have seen methane. So methane forms by the combination of hydrogen and carbon. Okay, so methane occurs in natural gas to the extent of 87%. Decomposition of organic matter in the absence of air produces methane. In the absence of air, decomposition of organic matter, we are getting methane. Methane present in biogas. Methane is present in biogas. Methane is found in coal mines. Methane is found at the surface of marshy places, which is why it is also called marsh gas. That gas is called as marsh gas. On heating a mixture of hydrogen and carbon monoxide gases at 300 degrees Celsius in the presence of nickel, methane gas is formed. Fractional distillation of natural gas gives methane in pure form. So the way which we are getting methane, these are the ways are given over here. Due to all these manner, we are getting methane. While decomposition of organic matter, while biogas plant, in coal mines, or we can say it at marsh gas, or we can say this with the help of nickel, methane gas forms, and we can say that the fractional distillation of natural gas gives the methane in pure form. Here are the few physical properties of methane, and these are: melting point of methane is minus 182.5 degrees Celsius. Its boiling point is minus 161.5 degrees Celsius. It is a colorless gas. It is not having any color. The density of liquid methane is less than that of water. Methane is sparingly soluble in water. It is highly soluble in organic solvents like gasoline, ether, and alcohol. Methane is in gaseous state at room temperature. Next is chemical properties of methane. Methane is highly inflammable. It burns by reacting with oxygen to give bluish flame, which is having at our home also. In this reaction, 213 kilocalorie per mole of heat is given out. Methane burns completely. And the chemical reaction is methane is highly inflammable with oxygen. That means CH4 plus 2O2. And what is coming out? Carbon dioxide, 2H2 and heat. Its chlorination form. Methane and chlorine gas react with each other at the temperature of 250 degrees Celsius to 400 degrees Celsius in presence of ultraviolet light and form mainly methyl chloride, which is having IUPAC name chloromethane. All these things we are having in detail in your 10th standard. So you just have to keep in your mind this thing is happening. How it is going to form, that thing you will clear with in your 10th standard. Okay. And this reaction is called as chlorination of methane. Its chemical reaction is CH4 plus Cl2, which we are getting chloromethane, which is CH3Cl, and hydrochloric acid is forming. Here are the uses of methane. Methane in the form of natural gas is used in industries such as fabric mills, paper mills, food processing industry, petrol purification. Being the smallest hydrocarbon, the proportion of CO2 released in the combustion of methane is small, and therefore it is used as a domestic fuel. Methane is used for production of organic compounds such as ethanol, methyl chloride, methylene chloride, and acetylene. These are the uses of methane. We'll stop our lecture over here. Your homework is you have to write occurrence of methane, its physical properties, chemical properties, uses, all these things you have to write as a homework.